Okay, so we went over how to use your online textbook. So I need that open. I need that back on page 2. I've made a mess of my online textbook, but that's okay. So don't get overly excited with whatever you're doing. So we're going to go back to page 2 in your text, and I'm going to go over the high points of this lesson. I'll try to keep it fairly short. All right, everybody ready? If not, push pause and come back when you are. All right, here we go. Okay, so my lights went out. It'll be all right. You'll be fine. We're going to go back to page 2. So I'm going to click right here. I'm going to say page 2. And this is where you're starting. Now you're going to go through my little lecture with me. I know you're excited. Give it a minute. But the first thing I need you to do is I need you to write down what you know about chemistry. So this is called a KWL chart, and we're going to use one every time we start a new section. So we're going to start with KWL. And what do you know is going to go in that left part over there? What do you know is going to go in the left part? So you're going to put what you know right here. What do you want to know? What do you want to find out about chemistry? And then at the end, I'm going to probably forget, but I hope you'll come back and look at what you wrote down. So anytime we start a section, I just want you to put down K, W, L along the column of your paper. And I want you to fill in, what do you know about chemistry? The idea here is chemistry is the study of everything around us. What do you know? What do you want to know? And what have you learned when we come back to this? So put a little star. We got to remember to come back. Now push pause and fill that in. Push play again when you're finished, and we're going to keep moving. The essential questions for this section. So these are our goal questions every time. What is a substance? How does ozone form and why is it important? And what are chlorofluorocarbons and how do they get into the atmosphere? I say weird things sometimes like chlorofluorocarbons. Sorry, it's kind of like the dude from Frozen. So if that helps you, awesome, do it. If you just want to make fun of me, that's totally fine. I'm a big girl, I can handle it. But these are the questions we want to answer by the end of this lesson. Here's our vocabulary. Now, friends, I know that sometimes you're like, I don't remember some of these words. If you will flip the page in your e-text or text to page 4, you'll see the start of this section that we're compiling here. So when you see that, and I can't go back and forth very often in PowerPoint, it kind of throws a fit. But if you look in the yellow section on page 4, you'll see those essential questions that we talked about. And then you're going to see your review of vocabulary. So you're like, matter, yeah, okay, I know what matter is, but what exactly is it? You can go find it right there on the first page of every section in the yellow part. So it says matter. I want you to type in what it says right there to answer my question below, okay? So take a minute and you're going to push pause, and then I need you to tell me what matter is, okay? Okay, so the new vocabulary, and guys, your vocabulary definitely shows up on every test. It'll show up on every quiz, maybe on exit tickets. I'm very picky about vocabulary. So if you're an index card person, buy some or come see me and I'll give you some. And write out on the blank side of the index card, you're going to put the word. See, look, see how much I love them. You're going to put the word, and on the back, you're going to put the definition, big enough where you can see it, but don't let it bleed through. With Sharpies, it gets messy, so be careful, okay? Now, the new vocabulary for this section is chemistry and substance. Obviously, chemistry should be our very first vocabulary word. That's why we're all here. And then what in the world is a substance? Now, don't get all Breaking Bad on me about that. We're going to talk about it and stay with me, all right? So, why do we study chemistry? Everything in the universe is made from the building blocks that were formed in stars. The building blocks and everything else that make up stars, that make up everything in our universe, are called matter. Chemistry is the study of matter and the changes that it undergoes. That sentence right there is exactly what we do all year long. We study what makes up matter, how's it put together, what are its very tiniest parts, how do they come together to make new pieces of matter, and the changes that we can do with matter. Does it give off energy? Does it take in energy? Does it make an explosion? What does it do when these things are combined? So if you notice, this is highlighted. So I need you, anytime you see a highlight, oh my goodness, go back. Anytime that you see a highlight, I need you to make sure you write down that word and that definition. So always be sure you get that. Chemistry is the study of matter and the changes it undergoes. Guys, I move quickly to keep these videos short, so you may have to pause me and write down that word and write down its definition, okay? You should be old enough by now to be able to do that without me telling you. I'm being very loving in this first video, but after that, I'm gonna be going. So be ready, okay? All right. Now, we talked about chemistry. We need to talk about the ozone layer. This is our phenomenon. The ozone layer. What in the world is it and what's going on with it? So the ozone layer is basically made up of a different type of oxygen, and it protects us from the UV radiation of the sun. So let's go through this. The UV radiation, ultraviolet UV radiation, damages living organisms. It can alter cells. It can cause crazy growths. It burns your skin. And the Earth's atmosphere has a layer of ozone that absorbs most ultraviolet radiation and protects living organisms. Does it stop all of it? No. But basically, the ozone layer is the sunscreen of the Earth. Okay, we put on sunscreen to block ourselves from the extra UV that's coming through, and then we're mainly shielded from this layer that we've got all around the Earth. And you're going, what in the world actually is ozone? Ozone is technically, its molecular formula is O3. So it's made up of 3 oxygen molecules, and we'll see that here in a few minutes. We'll come back to that. Okay, so let's talk about what a substance is. Since ozone's a substance, what in the world is substance? There it is in bold, gotta write it down. A substance is also known as a chemical. A substance is known as a chemical. So those two are interchangeable. And it is a matter that has a definite composition. So chemicals have definite compositions, and so do substances. That means that it has a formula, and we'll go over what formulas are, but think about O3, CO2, H2O, and if none of that makes sense, just wait, it will. But most of you know that those are the formulas for oxygen, O2, ozone, O3, CO2 is carbon dioxide, and H2O is water. So those are very common formulas that you interact with in your everyday life. The atmosphere has several layers. So here we're going to look just briefly because this is not my jurisdiction. But the layers that we're talking about here, the layers of ozone, excuse me, are in the stratosphere. So here's the troposphere. That's the lowest one, and it goes up to 10 kilometers from Earth. The ozone layer sits within the stratosphere, so that's from 10 kilometers above Earth to 50 kilometers above, well, let's say sea level. Then the mesosphere is from 50 to 85. The thermosphere, which is where space shuttles will travel and meteor trails will be seen. And the satellites are up in the exosphere, so that's 500 kilometers from Earth. That's way out there. Jets fly at about 10 kilometers up. So just to keep that in mind, kilometers is kilometers, so it's meters. Kilo means 1,000, so it's 1,000 meters from the Earth's surface. Okay. Ozone in the stratosphere is formed when oxygen, which is normally in our atmosphere, is exposed to that UV radiation. So here's my normal little oxygen bubbles. Here's my little oxygens, right? UV light from the sun comes in and hits them. What happens? You see this arrow? That means change has occurred. When that happens, it's basically going to pluck off an ozone, or sorry, it's going to pluck off one oxygen and it's going to form with another one. One oxygen atom with one oxygen molecule. So O2 is how oxygen naturally forms. It's always in pairs. So this is what we breathe in, and this is how we do cellular respiration, is with this oxygen. This is how we breathe and move everything through our bodies. And when we add another one, it becomes ozone. Ozone is not able to be breathed in, okay? So here, one of these guys splits. One oxygen goes to this molecule. One oxygen goes to this molecule. So it goes from O2 to being 3 oxygens, so it's O3. So that is the formation of ozone. So it's very interesting. If you think about it, this UV radiation comes in, gives its energy to this oxygen molecule, and it splits it. When it splits it, we get an O3 molecule. So if you look, this is the conservation of mass all being shown. You started with 3 O2s. Friends, what is 3 times 2? Or how many oxygen molecules are over here? 1, 2, 3, 4, 5, 6. When it splits, we lose an oxygen and it splits into oxygen atoms. But when we're done, we have 2 O3s. So how many atoms again? 1, 2, 3, 4, 5, 6. Conservation of mass or conservation of matter. This is a perfectly balanced pictorial equation. All right. So ozone has been studied since the late 1800s. Now, can they send satellites up there to study them? No, but we can look at where the ozone is most frequently noticed, found, and we can figure out what's kind of happening with it. So if you look at the second bullet point, it says ozone forms over the equator, where the rays of sunlight are the strongest. So if you remember, our Earth is on an axis. I apologize, this jacket's really gross. Our Earth is on an axis, so it sits at an angle. Can't precisely tell you which one it is. And here the Earth is rotating around, okay? So if the Earth is rotating, the part that's constantly getting hit by the sun is going to be that equator part. That's why it's mostly sunny there. That's why the temperature's hotter there. You've heard all these things your entire life. So the ozone forms there because that's where most of the UV light is hitting. That's where the ozone is being produced, and then it flows towards the poles from there. So we can really watch how the air in the stratosphere changes as we watch this change in ozone occurring. In the mid-1980s, this became a big deal. They started to see that there were areas in the ozone layer that were becoming thinner. And that was happening over Antarctica. Question: what's causing the ozone hole? Why is the ozone layer depleting? You're going to answer that in just a minute, or you're going to tell me what you think. What could be causing the hole in the ozone layer? Okay. If you cheated, which I don't think you could have, but if you did, you would see it's something called chlorofluorocarbons. Chlorofluorocarbons are very hard to say, and we're going to shorten it here in a minute. But in the 1920s, large-scale production of refrigerators started. Everybody needs what they used to call an icebox. And it used ammonia to cool it. So it's not like the ones we have today. We stopped using that at a certain point, but that was the fastest way they could find to cool down these big giant boxes. So Thomas Midgley Jr., you're going to be tested on that, don't stress. He synthesized the first chlorofluorocarbon in 1928. Ammonia, if you don't know, has a very, very strong smell and can make people very sick and lightheaded. So we were trying to find something safer. So we came up with these chlorofluorocarbons. And we're going to shorten that to CFC from here on out because I love you, but I'm not saying that word 900 more times, okay? A CFC is a substance that consists of chlorine, fluorine, and carbon. Gee, who would have thought with this name, it's made of chlorine, fluorine, and carbon. And if you don't know, those are 3 elements on your periodic table. If you'll take just a minute, I want you to go find their numbers on the periodic table. We call that the atomic number. Okay, so find the whole number that goes with those and fill it in. Okay, so all substances that are classified as CFCs are man-made, non-toxic, and stable. If it's a CFC, it has to follow these 3 things. It has to be man-made, doesn't occur naturally, cannot be toxic, and has to be stable, meaning it doesn't just react with anything else. Okay, these seem to be ideal for us. We were like, yes, we finally got something so we can cool down these refrigerators and the AC units that were made and not cause any massive damage. They're also used in spray cans. So think of your aerosol cans that, you know, you're spraying hairspray, you're spraying Lysol. Any of those use CFCs to help propel the droplets out of the can. Awesome. So we have CFCs. We make these CFCs and then we start finding them in the atmosphere in the 1970s. And the concentrations increased over time. So this says PPT. Here's our axis here. We're measuring chlorofluorocarbon 11, so it's a certain mass of chlorofluorocarbon, and it's parts per trillion. So how many parts were there per trillion parts of air? So it's like a ratio, right? Like 1 out of 5, like 1 out of a trillion. That would show up on our graph, 1 out of a trillion. This is 140 parts in 1977. 140 parts of air, or 140 parts of CFC per trillion parts of air. Okay. Now, when you start to see that, you start to see it increase and it doubles. It almost doubles from 77 to, let's say, 90. So a little over 10 years, the amount doubles. That starts to be kind of scary. Could there be a connection between the ozone thinning and increasing CFCs in the atmosphere? Maybe. Maybe. We're going to find that out. So again, I need you to answer these questions. What's a substance? How does ozone form and why is ozone important to us? What are CFCs and how do they get into the atmosphere? Or how did they get into the atmosphere? Let's start with that. This is section 1. You guys have done great. Please be sure that you finish up any other assignments that there might be. And trying to get out of here. That's that. Bye.